Hi, my name is Oktay. Welcome to today's video about the planet Venus. This is a nice picture of the planet Venus. It's the second planet of the solar system. Its name comes from the Roman goddess of love, fertility, and victory. This picture is from the Mariner spacecraft. Venus is at a distance of 0.7 AU, which is 108 million kilometers. 1 AU is the Earth's sun distance of 150 million kilometers. Venus has about 81% of Earth's mass. Its orbital period is 225 days, and orbital speed is 35 kilometers per second. This is a nice picture of the planet Venus. Its reflection on the Pacific Ocean. Here is Venus. At the top, that's Jupiter. And the right time to observe Venus is during dusk or dawn. This is another image of Venus. That's a UV image. You can see the dense clouds. For decades, it was not clear what is hidden under these clouds. So in the 1930s to 1950s, there was speculation that maybe Venus is a jungle planet or an ancient version of Earth. This is a movie from pictures of the Magellan spacecraft. You can see the clockwise rotation of planet Venus. Its axial tilt to orbit is 177 degrees. Rotation period is 243 days. That makes the Venusian day longer than its year. And there's a near 13 to 8 orbital resonance with Earth. So in 8 Earth years, Venus completes 13 orbits. This is an artist's impression of what happened to the Venera 7 when it landed on Venus in 1970. That was the first successful landing on another planet. But the spacecraft could only send a signal for 23 minutes because it was exposed to the dense atmosphere with 92 bar pressure, main component CO2. The temperature on Venus is between 437 and 497 degrees Celsius. That makes Venus the hottest planet in the solar system. And this spacecraft was destroyed quickly by its pressure, temperature, and vapors of sulfuric acid. This is a map of all the landings of the Venera spacecrafts on Venus. Over here, Venera 13. 11, 12, and this map was made from a combined topographic data of Magellan and Pioneer and Venera. This is a colorized picture from the Venera's 10 mission of the surface of Venus, and there's no chance for life because of the combination of the hot acid vapors, high temperature, and high pressure. This is a spectroscopic analysis of the planets Mars, Earth, and Venus. You can see the strong signal of the molecule carbon dioxide, but only planet Earth has additional signals of molecule ozone, O3, and of the molecule water, H2O. This is a comparison of the planet Venus to Earth. Venus is a little bit smaller than Earth and has about 81–82% of Earth's mass. Average temperature is 464 degrees Celsius. Pressure is 92 times that of Earth. And the reason is Venus has a runaway greenhouse effect. Planet Earth has also a greenhouse effect, but it's a mild greenhouse effect. This is essential for life because it lifts its average temperature from under 0 degrees Celsius to above 0 degrees Celsius, 15 degrees Celsius. That makes liquid water possible, that makes life possible. And we want a mild greenhouse effect. This is a picture of the Venus transit of 2012. Orbit of Venus is inclined by 3 degrees to Earth's orbit, which is called ecliptic. This transit causes a brightness dip of the Sun of less than 1/10,000. For comparison, Jupiter causes a brightness dip of 1% because it's a much bigger planet. And these transits occur in pairs. For example, there was one in 2004 and 2012, and the next transits will be in the years 2117 and 2125. This is another picture of planet Venus. It's a hemispheric view from the Magellan mission from 1990 to 1994. That's from the data from the Magellan radar altimeter. This is a picture of the internal structure of planet Venus. It is similar to Earth. It has a crust, rocky mantle, and a metallic core. But the difference is there's no plate tectonics on Venus, and there's no global magnetic field. This is a picture from the surface of Venus. There 3 impact craters in the middle. That's Saskia. It's a size of 37 kilometers. Top left, and that's Danilova, size 48 kilometers. And at the top right, that's the crater Aglaonis, with a size of 63 kilometers. This is the region Alpha Regio. It has a size of 1500 kilometers. It is located in the southern hemisphere. Alpha Regio was discovered in 1964 by Richard Goldstein. And this type of structure is called tessera, which is a highly deformed surface, and it's elevated. This is a volcano in the Isla region within the Alpha Regio region, and it has a shape like a tick. These are pancake volcanoes in the Isla region. They have a size of 65 kilometers, and they were formed from viscous lava. This is an animation of Akruva formation. These are 1 to 10 kilometer sheared plains in 100 kilometers clusters. The origin is volcanic, and on Venus there are 14 of these formations. This is the arachnoid Trotula corona, which is a spiderweb structure. Its origin is unknown, and there are over 90 of these structures on Venus. This is Mart Mons. It is a 8 kilometer high shield volcano. Its size is 395 kilometers. This is a 3D picture from the Magellan radar images. This is an animation of the Envision, which is a Venus mission of the European Space Agency. Launch is planned for 2031. It will do mapping and determine the activity of Venus, and it is capable of isotope analysis of the deuterium hydrogen ratio on Venus. This is Veritas. It's a planned mission of NASA. It will do radio science and analyze topography and the spectroscopy of planet Venus. This is a nice artist concept of a NASA station above the clouds of Venus. This is the planet Gliese 486b. This is our artist concept of how its surface could look like. The planet orbits the red dwarf Gliese 486, which is located at 26 light years distance. The planet is just a distance of 0.02 AU and has a mass of 2.8 Earth masses. We calculate the surface temperature as 430 degrees Celsius, which makes this planet a super Venus planet. This is a nice picture, artist concept of how terraformed Venus could look like. Venus has an advantage over Mars. Its gravity is 90% that of Earth. Mars is only 38%. And could it be that in history, young Venus would look like this? Because the young Sun had just 70% of today's luminosity, which means the habitable zone was much closer to the Sun. And it is possible that Venus had water, and then this runaway greenhouse effect occurred, and Venus lost the water and became how it is today, as a hot, hostile planet for life. That was today's video about the planet Venus. Thank you for watching. Have a nice day. Bye bye.